A warm welcome to all the viewers. Friends, have you ever wondered that which kind of sample size estimation method is best suited to your data, is best suited for your research objectives? So I am here to address this concern. You can see that there are several softwares and packages available through which you can assess the sample size before you actually go out in the field to collect the data. That is known as a priori sample size estimation. But confused, right? Which one to be used, right? I have seen people being using different softwares for sample size estimation, different rules for calculating the sample size manually as per their structural equation model. But there is a lot of confusion on how to use, which one to use, when to use. For an instance, many people use G power for structural equation modeling sample size estimation. But actually, G power is meant for statistical data standalone techniques. Standalone statistical tests like ANOVA, t-test, regression. These kind of tests can be done through G-power. The sample size can be estimated for these tests in G-power. Then we have PowerSem. So this is a R package. You need to install it in R, but there's a Shiny version also available, Shiny app, which you can directly use on the internet, use it online. Then there is SEM power. SEM power is basically a application, again an online application which helps you to estimate the sample size for structural equation modeling. Power SEM and SEM power both are meant for covariance based structural equation modeling, whereas PLS SEM power is especially suited for estimating the sample size in case you are doing variance based structural equation modeling or partial least square structural equation modeling. ISRM, that is inverse square root method, and gamma exponential method. Both of these are techniques suggested by an eminent article by Koch and Hadaya in 2018. So PLS SEM power Chinese application can help you to assess the sample size based upon ISRM technique for partial least square structural equation models. So let us start why it is important to know the sample size before you actually go out to collect the data, and which out of these softwares can help you do it. So first we look into what is the importance of sample size estimation. Yes, statistical power. It ensures the study has a high chance of finding a real effect or difference if it exists. Because if you fail to reject a false null hypothesis, that is known as false negative or type 2 error, this can happen when the sample size is too small to detect a real effect. So in fact, when you have a real effect but you fail to detect it, that is known as type 2 error, and this can be attributed to a lesser sample size, lack of sample size for estimation. Second is precision and accuracy. It narrows the margin of error so data estimates closely reflect the true population. Why do we collect the data? We collect the data to conduct a study upon a certain number of individuals, certain number of samples, and then infer the findings, results on the entire population through which those random samples was taken, right? So it increases the precision and accuracy, the stability and reliability of your results. Then ethical responsibility. It prevents exposing too many humans or animal subjects in case you are doing a biological research to unsafe interventions or wasting time and resources on an underpowered, inconclusive study. So a study must have sufficient power. The data should be there to give sufficient power to the statistical test to detect an effect, a true effect, right? Then resource management, it saves money, time and materials by preventing unnecessarily large data collection. Now we move on to these methods and see what is the difference between all these methods and when to use which one. This is a beautiful chart which I have put in so that you can understand the entire concept of using G power, power SEM, SEM power, PLSM power and ISRM technique and gamma exponential method. So there are several articles available on the internet which you can download for free and study about them. But for now, the purpose of this video is to introduce you to different sample estimation techniques so that you can select the right sample estimation technique for your data analysis. And there are R Shiny packages available for that, which you don't even need to install the package in our software and run it. You can directly run it on the online interface. I'll show you in a while. So you see here, G-Power is meant for general purpose statistical software. It is neither specifically cbsem or plssem, whereas PowerSem is applicable for cbsem, SEM Power again for cbsem, but there's a difference between PowerSem and SEM Power. Now, ISRM is a technique which is employed by PLS SEM Power, right? But GEM has to be done manually, or you can use WARP PLS, WARP software for estimating the sample size for PLS SEM using ISRM and GEM technique. So then we look at main input or basis. So here in G power, you need to mention the effect size, the significance level that is denoted by alpha, power, predictors, degrees of freedom, etc. depending on the test you select, right? Whether you want to do a T test, ANOVA or a Z test, you want to specify all these things. Then specified structural equation modeling, target parameter or effect, significance level and desired power for power cell. Then model implied covariance structures, effect or misspecifications, power, significance level have to be specified in SEM power, and expected minimum path coefficient between your variables has to be input by you while estimating the sample size through PLS SEM power. Along with that, you need to specify the significance level and power of the test, which is usually kept at 0.80, which is recommended in social sciences studies. Then we look at accounts for latent variables and measurement model. No, G power does not, because when you go into structural equation modeling, you have latent variables and you assess the confirmatory factor analysis, that is measurement model. But for G power, as we are testing the basic statistical test, there's no measurement model and no latent variables involved. In fact, you have the composite scores of the variables when you are doing a simple regression, ANOVA or t-test, right? Then you have power SEM, yes, it accounts for that. SEM power, yes, and PLS SEM power accounts for PLS specific, and ISRM and GM both techniques are designed around PLS path coefficient. So in case you are going in for PLS SEM, then you must estimate the sample size using PLS SEM power. In case you are doing a covariance based structural equation modeling, say in amos or in R, then you should use power SEM power. Out of these two, power SEM or SEM power can be used. If you are doing a simple analysis, say in a software like SPSS, you are doing ANOVA, you are doing t-test, then you can go ahead and use G power. Even in case of multiple linear regression, when you want to do it in SPSS, you can go with G power. Then whether it can determine the sample size for a specific structural path indirectly by treating a structural relation as regression. So, but in regression and structural equation modeling, the difference is that the path coefficients are assessed separately, individually in regression, whereas in structural equation modeling, all the path coefficients are assessed, all the relationships are assessed simultaneously. That is the difference in regression and structural equation modeling, right? Can assess overall SEM model fit power. So here you see not as a structural equation modeling, not its primary purpose. The primary purpose of power SEM is not to assess the overall SEM model fit or power. But in SEM power, you can assess the overall SEM model fit or power of the model. In PLS SEM power, not a global cbsem fit analysis, because you are doing PLS SEM where global model fit indices do not apply. They apply in case of cbsem, right? You just need to go to G Power and you will get a website like this from where you can download the G Power. You see here, download the G Power manual, download the short tutorial of G Power. Okay, so you can download it like this, and then you can download G Power for Windows from here. When you download and install it on your system, it will look like this, wherein you can conduct the test family has to be selected, whether you want to do t-test, f-test or z-test or chi-square test or exact test. and then you select the type of test under that test family, and then you put a priori, that is compute the required sample size giving the alpha, power and effect size. A priori means before the actual data collection, and post hoc means after you have collected the data, you want to see the power of your test. So this is how G power interface looks like. Next we see SEM power. So when you go to SEM power, you just have to type on Google SEM power and the application will open on online interface, and the interface will look something like this. SEM power, power analysis for structural equation modeling, where you have to put the desired power, significance level, that is 0.05, effect measure, what you want to use in case you want the model fit, effect size, degrees of freedom, number of manifest variables, that is observed variables or indicators, right? And this is the citation which you must quote when you are using this for your data analysis in your article, thesis or dissertation. You must put this citation for SEM power. Next we see power SEM. So again you go to Google and type power SEM and you'll get this thing. There you want to cite this Wang and Rematullah. So this paper came out in 2021 and they have described the method to use power SEM for estimation of sample size in case of covariance based structural equation modeling. Here you have to specify the model and then you visualize the model, set parameter value. So here you can adjust the sample size and you can check the power. So if it meets the required desired level of power, you can go with collection of that minimum sample size which is prescribed by power SEM. Next, we go to power analysis of partial least squares. So once it opens up on your browser, power analysis of partial least squares, you have to again mention this citation positively Ansani and Renalo 2025 PLS SEM power version 1. So you have used this for estimation of sample size and it works on inverse square root method as prescribed by Koch and Hadaya 2018, and MDS, which stands for minimum detectable effect size, has to be put over here. So once you put the significance level, you select the analysis type, a priori or sensitivity analysis, given the sample size and compute the MDS, and given MDS compute the sample size. So this is a priori. Sensitivity is once you have collected that data, you want to know whether you have the sufficient power in the test or not. And then you select the MDES and you will get a graphical view of how much minimum sample size is required to detect an effect of zero point 0.2, as we have selected the minimum detectable effect size in this case is 0.2 with 80% of power, and p-value of 0.05 is 155. So we have selected the p-value is 0.05, that is we are conducting the test at 95% confidence interval. So these are the four softwares or packages you can say which you can use to estimate the sample size effectively for your structural equation modeling or for your basic statistical data analysis via G Power software. So I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.